Okay, good evening, all. Welcome to one another bite-sized learning. So, I think the last time in April we did on chatbots, and this time we have got another interesting topic on machine learning. We have got Rajesh Koneru, a senior associate from Development Bank of Singapore (DBS). Rajesh has got over than 12 years of experience in various technology. He started from mainframe assembler and now doing data analytics in R. He's a kind of a person who keeps things simple. And many thanks to him for volunteering and taking up the session on machine learning for ISACA Hyderabad chapter members. As regular announcement, as Shiva said, please keep yourself on mute for the next 1 hour. And if you have any questions to the speaker, you can always put your questions in the chat window. And towards the end, Rajesh will take up and answer the question. For the benefit of all, this complete session is being recorded in Zoom, and it will be put in YouTube and shared in the ISACA Hyderabad chapter website as well. Thanks to everyone for joining. Over to you, Rajesh.
Hi everybody, Ganesh, I hope you can hear me.
Yeah, you're loud and clear. Go ahead, Rajesh.
Okay. So I'm now sharing my screen and we would like to start with the knowledge bytes for machine learning. So I hope my screen is visible.
Yes.
So the intention of this PPT is to make make the even the ordinary people understand what machine learning is. So here is the agenda. Okay, just a moment. Okay, so the agenda is we are going to understand what is machine learning and why is it prominent now, what are the different kinds of machine learning, and I will also show you some demonstration of how the machine learning happens. And probably we will see what is the data value change that is currently being prominent in the recent world. Okay, so let's start with what is machine learning. So according to the Arthur Samuel of 1959 definition, this is a field of study that gives computers the ability to learn without being explicitly programmed. So the meaning is that the computers or any other electronic gadgets or any other machines, they need not be programmed to do a certain task. They will have the ability to learn the task and do the analysis on their own. This is just like the child's picture, which you are seeing on the screen. So the child is not is trying to construct a house or probably assemble a toy here, but she does not know how to do it. There is no step-by-step procedure. She is learning that by trial and error. So that is what is basically machine learning. To put it simply, it has got access to vast amount of data and it learns to identify things through trial and error. Okay. So now let's move on to the next aspect. So what is many people get this doubt of this, what is machine learning and is it some kind of a programming or not? So I'm going to show you some kind of differences between them. Okay. So put it simply, programming is like you have got a toy with specific features and you're assembling it. And machine learning is like the example that I've shown. You have got different blocks. You don't know how to assemble. You'll just put them one on another and you'll try to figure it out. And to be specific, say for example, we have an input data, we do a process and we get an output. Now we will see how is programming and machine learning are different in this simple process. In programming, the process is already defined, so we know what to do. While we have the input, we know what to do with the output, so we can easily expect what the output is going to be. But in machine learning, the process for the output is being determined. That means we have input, we have output, and we try to determine what is the process by which this input has turned into this output. This is where the learning part comes in. And this is why machine learning is called as the first part or the stepping stone for artificial intelligence. Okay, so machine learning is being a part of artificial intelligence. When the machines are trying to understand the process themselves, that means they are trying to develop the intelligence themselves. So that's how this is leading to artificial intelligence. So let's see the other differences. There is no trial and error involved in programming. Say, for example, if I have to build this house, I have the base given, I have the top given. There is no trial and error on this. Put the base here, put the top here. But if you see here, the blocks are of the same size. I can put one block here, one block there. I can make the house in any form, or I can make the toy in any form. So there is no trial and error involved in programming, and there is no trial, but there is a lot of trial and error involved in machine learning. So to be specific, to give a real life example, if we have to calculate the simple interest when principal, time period, and rate are given, then it is programming because we know the formula, we know the program. But somebody says, I give you the principal, I give you the rate of interest, and I give you the interest, determine the formula for simple interest. That is machine learning. So you are trying to determine the process here actually. You have some input, sometimes you'll have the output, sometimes you may not have the output also. So that is where the crucial difference comes. Now in programming, the success rate is 100%, and the success rate varies based on the quality of data. So what does the success rate here means? Since we know what is the input, since we know what is the process in programming, there is no wonder that the output is always as expected. It should come as expected. But in machine learning, the main aspect is that we know the input, we know the output, we have to determine the process. So we cannot make any conclusions or anything which 100% surety unless we are very much sure on the quality of the data. So next, there is no dependency on the data if you are talking about programming. But for machine learning, it is heavily dependent on the data, both on the volume and on the quality of the data as well. Okay, so let's go on to this prominence. Why is machine learning becoming prominent now? As machine learning is commonly known as ML. So let's understand why is ML prominent now. Okay, so I want you people to have a look into this image. Okay, some people would have probably guessed this. This is the image of IBM actually shipping their 5 MB memory device. Okay, 5 MB memory device. And suppose if you time travel, suppose if I time travel to this location, and you imagine this is me, okay, then I'm holding a 1 TB device. So if I'm holding a 1 TB device at that time, this is how small it would look like. Okay, this is the 5 MB memory device, and this is the 1 TB pen drive, which is commonly used now. So that means you can visualize the difference that has come up here. There is a whopping 200,000 times amount of data storage. That means you can, in this space, you can either store 200,000 times 200,000 pen drives, or it could be sometimes the other way. The amount of storage this has, that multiplied by 200,000 times, is what is there in this minuscule part, the pen drive. This is one of the first prominent reason why machine learning has become prominent now. Why? Because the storage has become cheaper and accessible. So when the storage becomes cheaper and accessible, let's see what happens. If any of you have seen Iron Man movie part 1, probably you can remember the dialogue. It says that this is a heavy machine. It can run for 100 years. Or as Tony Shaw says, or it can run a very big machine for 1 year, or it can run a very small machine for 100 years. So Tony Shaw chooses the other thing. He says that I will take a big machine and I'll run it for 1 day and I'll save the world. So that is what happens with humans generally. When this memory compression happens, we are no longer worried about the data storage. Okay. So when we are no longer worried about the data storage, then there is an incentive to create the data. So what do you mean by incentive to create the data? Just a moment. Okay. So when there is no worry for the data storage, then there is an incentive to create the data. Like number of mails increased when storage limit is removed by Gmail. And number of messages increased when WhatsApp became prominent. So this is how the trend of the world is. Now, when there is an incentive to create a lot of data, then there is lot of data available for us. Then there is no worry for us to do a trial and error. Okay. So let me repeat the sequence of steps to you. When there is no problem for data storage, then there is always an incentive to create the data because we have a lot of storage available. When we have a lot of storage available, then trial and error on the data is not an issue. And remember, machine learning is about trial and error. So when trial and error is no longer an issue, the learning can be done either by a post-processing human brain or a relatively slow processing computer. Yeah, because computers are still relatively slow processing computer compared to human brain. So what is the outcome? Who is the winner? Anyone who has large volume of data and who can process large volume of data is the winner. And that is why machine learning is becoming prominent now, because machine learning through its algorithms gives us the capability to process large volume of data. Now, having large volume of data is no longer a problem because we have seen the data compression is happening very fast. But processing of large volume of data was a challenge before, but now that is no longer a challenge because of the latest technologies that are coming up. So now let's move on to the next part. Now, who has the large volume of quality data here? We can easily get Google, Amazon, Netflix, Apple, and Facebook. These are the companies which have got large volume of data as well as large quality of data as well. The quality of data is also good. And you might ask then, if Google is there, why not Yahoo? The point is, Yahoo has got a large volume of data. They do have a quality of data, but the processing is not there. So as I mentioned here, you should also have the capability to process that large volume of data. They did not implement that processing very well, even before Google. That's why they lost the race. But now they might have got the capability. But before Google, they were not able to implement this. That's why they have landed into this shallow waters now. Now let's move on to the next part. Now let's see what are the kinds of machine learning. As you can see, the first part is supervised machine learning. Okay, I'll explain to you what is supervised machine learning. Supervised means, as the name says, you are going to tell the system, you are going to supervise the system that this is our input and this is the output. So I'll pause here for a moment so that you people can understand what is happening here. Okay. Okay. So what do we observe here? We observe that on the first glance at intuition, we can easily say that for the input, the output is a square. Okay, output is the square of the input. So for a human brain, it is easy to predict that the next three results are going to be 49, 64, and 81. This is what human brain can process automatically. But how do you train the system? Okay, you can simply tell the system that, okay, if you get the input, square it and give that as the result. But that is not machine learning. That is actually programming. As I told you, you already know the process. So in machine learning, it is the process that you're trying to find out. So how do you do that? This is how we do it. Suppose we have 9 elements as data. We will take, say, first few elements as a training set. Okay. Then the next few elements as the test set, and the rest of the thing is actual prediction. So we take some amount of data as a training data. We will train it we will use our machine learning algorithm to train it. Then we will test it on the data, on another set of data. And if the results are satisfactory, then we will go into the real world or say prime time. Okay. Say for example, this is the input and that is the output. I have trained the system. After training, this is how my system is responding. Say for example, for 4, 5, and 6, my system is responding 16, 24, and 37. So as I said, the accuracy is not always 100%. So it is me who will take a call. Okay, I'm okay with this kind of accuracy. So I will now go down to the actual data and I will start predicting the result. So that is why there is only prediction involved here. This is what is supervised machine learning. I have a set of input, I have a set of output. I will train the system on that first training data, then I will test it, and then I will leave it to the real world. Okay. So there are some algorithms such as linear regression and logistic regression, which are basically used for this one. Okay. Okay. Before we go to artificial neural networks, okay, I would like to show you a demonstration of how this linear regression happens. Can anyone volunteer to say if they are able to see my code screen? Uh,
Yeah, we are
yeah,
able to see.
okay. So I'm now going to show you the data here. This is the data I have downloaded from Digital India government data.gov.in website. Okay. This is an Excel sheet which says what is the vehicle density, that is number of motor vehicles per thousand population during 2013, 14 and during 2014-15. Okay. This is a kind of a typical problem which many of the data analyst enthusiasts gets. It's like they have this as a breakfast kind of stuff. So this is the data in the erstwhile state of Andhra Pradesh, Arunachal Pradesh and all. Say for example, if someone says, okay, this is the data you have, and someone says, okay, I have lost this data on Puducherry, I have lost it for some reason, can you predict it? Okay. So this is the actual data given by government of India 488, but we shall try how to predict it. Okay. So how does a data enthusiast do? As I told you here, we will use the training data, we will test it, and then we will predict it. So that means I will take all this data for training and testing, and then I will use it on Pondicherry to predict the results. Okay. So I'm going to run the data because we have people from all background. I'm just going to run the program. If you want more details on this program, I can give it to you. I can share it with you. So this is the vehicle density data for 13-14 versus 14-15 on a map. We can see there is a linear relationship. So I know that I have to apply linear regression. Okay. So it is trying to predict the results. Okay. Don't worry about the messages that are coming. That is like it is trying to calculate these data. Okay. Now what is the program predicting? The program is predicting that if the motor density is 471 for Puducherry, then it is likely to have a motor density of 497.077. Okay. Well, the actual answer is 488. What the system is predicting is 497. Okay. So we can say what is it? The accuracy is about, okay, the error is about 0.1%. The error is about 1.8%. So you can say the accuracy is 99%. Okay. This is happening. So how did this happen? Suppose if you ask me, a layman like me, to predict what will be the value, I could have predicted any value. But here we have got a systematic way to predict the results, which are totally dependent on the vehicle usage of other states. So here I am assuming that the vehicle usage is going to be the same for Puducherry and other states. Now that is the beauty here. So what did I do? I trained my system based on a given amount of data, and I'm now able to predict the results. So now I can take this on and on any number of times. And that is how the machine learning happens. Okay. So this is a sample example for linear regression. Okay. So now many people ask, what is this regression part? I mean, are we doing kind of testing? So generally regression means that if you are using the data, or if you are using the mean value of an input data and try to predict the mean value of an output data, okay, that is called as regression. And if the data of input varies linearly compared to output, that is called linear regression. And if you are doing a prediction of zeros and ones, it is logistic regression. That is kind of, I went a bit deep into this one, but that's for the information if you need it. So I now like to move on to another set of regression, or sorry, we can say machine learning, called as artificial neural networks. Okay. So what is artificial neural networks? It's like it is used to. It is like it will do the analysis based on the way the neurons in your brain works. To put it simply, say you have got an example here. I hope you people can see the screen. This is a handwritten number 3 by a person. Okay, and there is a character recognition program through machine learning, and it predicted and it visualized the number like this. And based on this visualization, the neural network program is predicting that there is 79% chance that the given input number is 3. There is 42% chance that the given input number can be 5. and 40% chance that the given input number is 2, and there is a 7% chance the given input number is 1. So since there is a highest amount of chance for number 3, so it predicts that this number is 3. This is what is machine learning through artificial neural networks. An example. So what does it do? It will take the amount of data, it will get a large amount of results, it will find out the highest possibility, or what is the maximum success percentage, which number is going to get it, and it will show that result. This is how the artificial neural networks works. There is no right or wrong answer here. It will do it purely based on the percentage. I would like to show you the demonstration of this program now. I'm basically using a software called Octave, which I have learned during the Coursera course of machine learning by Andrew Ng. Okay, so I'm just calling this program. You can see here, these are the various amount of data. This is handwritten data by a person or a few set of people. Okay, this is the data I'm giving as input or training to my system. The data count is 1500, but here I'm only displaying the first 100 records randomly. So this is the data I'm giving as input, and I'll convert this data into pixel format and train my system. So once I train my system, I have to set some parameters to train my system. That is what is going on here. So you can see here, the system is learning based on iterations. Okay, it is trying to iterate, and I have set the iteration level to 50. So that means it will, after all the input data, it will try to learn it for 50 times and try to get to the best possible answer. Okay. Now it is ready, and now it says that it has trained itself on the input data, and its success rate is 95.68%. That means out of the 1500 handwritten examples that I have fed to the system, if I give the very same examples, it will predict it by 95.68% accuracy. So let's see how that happens actually. So it says there is a digit 8 and it is predicting it as 8. So you can see here, this is the number 8 written by a person, and my system is also predicting it as 8 because it has got a 95.6% accuracy. So let me try once again. So this is number 5. Okay, this could be a 3 which with the top part rubbed off, but based on the trained one, the system is predicting this as 5. Next, this is 1. This is 7. This is 3. Okay, so that is the advantage of this one. Now, how is this implemented in the real life? If you ask me, in real life, we can automatically see that it is already coming into many of our smartphone devices. Okay, that is a given, and it can also come down to any kind of information security and all these stuffs as well. Because here, what is it doing? It is having a hazy picture, and it is trying to get a probability of what could that picture be. Imagine this is a server form for us, and we have seen all the servers at these possible levels have gone for a toss. So then based on that level, it can predict whether this is a cyber attack, this is not a cyber attack, or based on the data. So that is the advantage of this machine learning, especially when we are talking into cyber security process or information security perspective. Okay. After this, I'm now going to move on to the next example in machine learning called unsupervised learning. Okay. So what is this unsupervised learning? Unsupervised learning means there is nothing right or wrong in this kind of a learning. Okay. So that means I have this cluster of data and I have to classify it. This is different from supervised learning because in supervised, I know what is, I'll show it to you here. I know what is the input and I know what is the output. And then I have to try to find out the process. And then we'll train the system, try to get the results. But in unsupervised learning, there is nothing like that. A typical example is classification. So on one random way, I have classified it as like this: like anyone who is having a expression of the face in the same format are in one group. People of expressing the facial expression in a different format or in another group. I can put it this way. Or I can also classify them in a different form. Like I can classify Donald Duck, um, Mickey Mouse, and Daisy Duck in one cluster, and I can put the other two, Bugs Bunny and the other duck, in another cluster. Okay. So there is no right or wrong answer. It's just the clustering that is important. That is classifying into different forms. This is called as unsupervised learning. Okay. So you'll train the machines and you'll ask them to find out the patterns. Okay. So say for example, if you have this kind of a data, as a simple individual, you can easily classify that this is one group, this is another group, and this is another group. Or suppose you have to determine the t-shirt sizes based on the weight and height of a person. So you can classify them as small group, medium group, and large group. This is quite easy when you can see the entire data in front of your eyes. But imagine with the vast amount of data that we are able to access now, if we have to do this kind of pattern recognition or this kind of classification. This classification is generally termed as clustering. This is one cluster, this is another cluster, this is another cluster. So if we have to do that kind of a thing, then you will obviously need an algorithm. And we use a machine learning algorithm called k-means algorithm for this. I'm not going to go deep into this, what is k-means and that stuff, but I'm just going to show you how that happens actually. Okay. Just give me a moment while I go to that program. Okay. So this is another set of data. Imagine this is the data. What do we say? A government is looking at, like people of this area are falling sick, people of this area are falling sick, and people of this area are not falling sick. They want to try identify the central location of this area. Okay. If we have huge amount of data, just pinpointing, just like I'm placing my mouse cursor here, that is not so easy. So when we have huge amount of data, especially when we are trying to find out the epidemics. If you say what is the equivalent of epidemic in an IT industry, like a cyber attack, yeah, you can call. I think we can call a cyber attack as an epidemic because incidentally we are using the same terminology, the virus attacks that happen on our systems. So suppose these are your server forms and they are getting affected. So you want to find out or localize where the attack is coming from. Sometimes you'll also not be able to determine which of the thing is right or wrong. See, for example, in this form, a majority of the area is affected, the rest of the things are not affected. Here, the entire form has gone for a toss. Here, a minuscule percentage affected, rest of them are not affected. So now, if you have a machine learning algorithm which will automatically try to find the central location of these clusters, then you can easily pinpoint where the problem is arising from. And probably you can even stop that as well. Okay. So let's see how that happens. I'm just trying to visualize this based on the data that is available. So for the first iteration, the machine is assuming that this is the center. This is where the error is coming from. This is where the problem is. This is where the problem. It is just predicting at 3 locations there could be a problem. This is random. It has chosen them as random. But now I'm asking the system to go for an iteration. At second iteration, it is trying to get to the center of this. So you can see this point is moving from here to here. This point is moving from here to here, and this point is moving from here to here. Okay. Ideally, if I know, I could have simply chosen the center here. There is nothing to learn. That's the reason why we have chosen intentionally far apart from the centers. And you can see the system is predicting the points towards the center. Okay. Say, for example, for the third iteration, there is some amount of learning. Now you can see there is a deviation coming up. We almost thought it is going to the center, but a deviation is coming. You can easily understand it is trying to go to the center of this location. Okay. So this is the fourth iteration. There is some progress, and the system is thinking, no, it is not going to happen here. Fifth, sixth. By sixth iteration, you can see we are almost to the center. We thought this is the center first, but it has learned to be this to be the center, and it has learned to be the center, and it has learned this to be the center. Okay. Let's say seventh iteration. It has almost gone there. Now it's eighth iteration here. Okay. Now many people ask the question that you say machine learning is iterations. Okay, the system has to learn, but how do you know when that the system has learned properly? How many iterations do you go? Whether one iteration is good, or whether 8 iterations is good, or 80 iterations is good? How do you determine that? So now, how does that happen in machine learning? That happens by the change that we are seeing. Okay. Say, for example, here we have seen a majority of the change in the starting iterations. We have seen a majority of the iterations change. Okay. But now from 8th to 9th iteration, we are not seeing much of a change here. Oh, I hope you people are noticing it. Okay. So when we see that not much of a change happening, so then we can understand that we have reached the center. Okay. It's like we are trying to push a door and the door is no longer opening. So that means we learn that, okay, there is not going to be a difference if we are putting more effort on that. So we will stop. We'll try to identify it in a different form. That is the same way exactly the machine is also doing here. Once it has learned, it has come to a position and it is saying that it is no longer bringing any change, it stops. Okay. And it says that machine learning is done, and this is the center. Okay. So now my machine learning algorithm has successfully classified the server forms into 3 categories: 1, 2, and 3. And based on this, I can make a decision. Okay. So this is how it happens in unsupervised learning. Okay. So unsupervised learning can be challenging a bit times. So I would like to repeat this once again for you people. Okay. So the point with unsupervised learning, as I said here, there is no right and wrong answer. If you ask me, I can combine these two as one cluster and this is another cluster. Even I can do that. That is also a right answer. Or I can classify these two as one cluster and this is another cluster. Even that is right. Okay. So you can see here, we have assumed this to be the center of the server. This could be the center of another server form, and this could be the center of another server form. Classification. Okay. And then we started iterating it. Now how is the iteration happening? The system is trying to take this one point and it is calculating that how close is this to all these points. It is trying to find out the mean of the distances and says that, okay, if I take this point and all these points, then this is the mean of that. This is the central location. If I take these points, this is the center. Take these points, this is the center. Okay. And then when it is trying to get the means, then then the system is finding that this is the next mean, this is the next mean, and this is the next mean. And that's how the means are moving. Okay. And at one particular point, you can identify the center location. Okay. And when you no longer see the improvement, that's when you realize that you have reached the central of the location and you have classified it. Okay. And that's how you are done. Okay. So this is how the unsupervised learning happens. So what is the major advantage of unsupervised learning? Generally, it is used in market segmentations, and in times of cybersecurity, it is trying to identify the epidemic forms wherever they have got hit. And it is generally used in aeronautical administrations as well. I'd like to pause here for a moment. I'll try to see if I can pull up one Excel sheet over here. Just a moment. Hi everybody, I'm back and I have just opened an Excel sheet. Okay, this data is from a book called Data Smart. Uh, this is available in the internet. Okay, that explains how to create a data analysis or machine learning with small examples from Excel itself. So that's why I have pulled up this sheet. Okay, so I'm going to explain you this this unsupervised learning, how this happens. So a person has got a campaign data for January. What is the kind of wine they have sent? What is the minimum quantity? What is the discount? What is the origin? And whether it has passed its peak or not. This is the data the person has. And this is the transactions the person has. So Mr. Smith has taken the offer of 2. Mr. Smith has taken 24. That means there is one person called Mr. Smith. He has taken this, okay, and he is also accepted this campaign, uh, okay. So like that, we have got the information of all our customers, and we try to find out if there is any trend, okay. So gone are the good old days when I personally recognize Mr. Smith and I know what his choices are. I personally know Mr. Brown what his choices are. So now when I have a huge amount of customers, I have to rely on the data. Okay. So what did I do? I did a same cluster analysis, just like I have classified them into 4 clusters, and I'm trying to get some analysis on this data. Okay. So I have placed all my people into 4 clusters, and in the first cluster, when I organize them, don't worry about the numbers, but when I organize the clusters, this is how I see. First cluster is like this one. Let me show you. Like this could be one cluster, right? So this is one cluster. So what do I observe from this cluster is majority of the people are loving Pinot Noir. Okay, people whoever fall in cluster 1, they love Pinot Noir. Okay, so all I have to do is find out who all are falling under cluster 1, who are our customers who are falling under cluster 1, and I know that they like Pinot Noir. That's how it is going. Easy it is going to be. Okay. So say for example here, say this is the person. So Mr. Anderson and so Mr. Bell. So if we go by this, they are most likely to like Pinot Noir. Okay, so you can see the data here clearly. They have opted for Pinot Noir here. That is one brand of wine. Okay. So similarly, if we go for 3 or 4, say for example, if I organize this by this, I can see here that in cluster 4, people are liking champagne more. Okay, not Pinot Noir wine. They are liking champagne more. And people in cluster 3, here also there is champagne coming up. Okay, and people in cluster 2, there is not much of a data analysis that I can get here. I don't have any quality amount of data here to predict. Okay, maybe I can say that okay, they're always opting for a minimum quantity of 6. So that means customers who are fall in cluster 2, they only prefer small quantities, not large quantities, or they prefer discounts above 50%. So this is how I have identified my customers in different dimensions, not only based on their choice of the product, but also on their minimum quantity, discount percentage, and all. And the beauty is what I have done all this with an Excel sheet, and that is what is the advantage of this machine learning these days. So if you have the data, if you have quality data, you can do that simply with an Excel sheet if the data is less. And if the volume of the data is high, then you have to resort to standard data analysis techniques. And that is where the data analytics, big data come into picture. Okay. So I think I have shown a pretty amount of demonstration. So I'd like to move on to the next part, which is what I call as the data value chain. So I want to conclude my session by explaining it to you what the data value chain is. Okay. In this entire data analysis, what the main for this data acquisition, how you acquire the data. Okay. Data warehousing, that means how you store the data. Next is data analytics, that means how you analyze the data. And plan of action, what do you plan based on the data. Okay. So data acquisition. Okay. Now Everybody knows how to do the plan of action. Once you visualize the data, the decision is simple, just like we have seen in our wine KMC example. But how do you do the analytics? This is where the different kinds of algorithms are coming up, and this is where our machine learning comes up. Okay, and our data visualization tools such as Tableau comes up. Okay, now what is data warehousing? You have to host that vast amount of data in somewhere, and this is where Amazon Cloud comes into picture. Okay, and now the actual question of data acquisition comes. This is the gray area. Okay, so that means people are ready to host. They have the help of Amazon. They can host a vast amount of data. They have the algorithm. They have machine learning techniques. They can analyze the data. They know the plan of action. But getting the data is the challenge. That is why companies like Facebook, Google, Apple, they are almost so prominent, and they're ruling their respective market share, their respective markets, because they have developed the ability to acquire the vast amount of data. And this is where the difference is coming up. When there is no longer a differentiation coming here, this is where the difference is coming up. And that is why the governments are also focusing that if this is going to be a differentiating factor, and if you are becoming too powerful, then there should be some responsibility also coming up into this. So this is what is I put up simply as a data value chain. Okay. So for example, if the data acquisition is constrained, like if government puts up rules, and if everybody is getting data equally, has equal share of data, then analytics would be the prominent one. But if analytics, plan of action, and data acquisition are fine, then data warehousing will be the most prominent one, because the more secure our systems are, the more ready and stable our systems are, the better analysis I can do. So that's how the greatness or the value of the activities differ based on the availability of the stuff. So if you ask me, in the current market, data acquisition is gaining more prominence than data warehousing because of the stability of the systems. And along with it, the analytics and plan of action are coming into picture. So this is the data value chain, if you ask me to explain into a layman terms. Okay. Now, these are my references, and I would like to thank Mr. Andrew Eng, who he is the person who hosted a course in Coursera, because of which I was able to do the entire demonstration. So whatever good is to him, and whatever silly mistakes I would have committed it because of me, I'm just an amateur, so I hope you understand that one. Okay. So I think I have come to the conclusion of my session. So, and I now open the house for questions. Ganeshan, over to you.
Yeah. So, team, if you have got any questions, requesting you to either unmute yourself and ask, or you can type it in the chat window.
Okay, this is my first question. Okay, Rajesh. So now there are so many machine learning this one. So which are the machine learning tools which are widely used?
Okay, so probably you can understand. Sorry, I could not get your name. Can I know your name, please?
My name is Shiva.
Hi.
My name is Shiva.
Hi, Shiva. See, it's like if you put it simply, it's machine learning algorithms are like medicines. Okay, and there is no single medicine to any cure. So we have to use the algorithm based on the problem. Just like I have explained, suppose I know the input and I know the output, then obviously I will apply supervised learning. Like I have told you, linear regression, logistic regression. These are the ones that I apply because I know the input, I know the output. Say, suppose if your company is having large, big problem with the spam emails. Okay, so I can have a set of data for spam emails. What are the common words that are coming up? Like you have won a lottery, or you have won a holiday. Those kinds of terms, and I can train my system with that. There, I will use supervised learning. Okay, but suppose you, as I told you in an example, suppose you want to classify the cluster forms where there is maximum amount of attack probability, vulnerability, or kind of usage, there you will use unsupervised learning. So it depends upon the problem that you are using. And these two are the commonly used ones. Whenever a person who is learning machine learning, they'll be using, especially related to IT. And other than this, there is something called as association rules, also called as market basket analysis. Okay, what the retail chains do is that they will try to identify that if a person is buying one thing, and is there any reason why he or she is buying the other thing. Okay, based on that, they will try to determine the patterns of the person. Like in one market chain, I don't know which chain, they found out that any person who is trying to buy a diaper, they are also buying the beer based on the spending list. And then what they did, they placed the beer cans and the diapers on the side by side, and then the sales of beer cans improved a lot, and even the customer satisfaction improved. Okay, there can be n number of reasons. Maybe the person buying the diapers is a father. Okay, and he's remembering that in the good old days when he was a bachelor and he's buying the beer. There can be n number of reasons, but this association rule helps them to identify this. Same is the case like with predicting the person who is likely to be pregnant. Walmart can do that easily because of based on the data that they have. So it depends upon the problem. And I gave you the examples that we generally use. I hope I answered your questions. Does that sound good, Shiva, or do you need
No,
any?
no, I think that's one more follow-up question.
Yeah.
So I know machine learning is now a very wide phenomenon, and it has entered into our day-to-day lives. Just
Mhm.
to appraise the group, can you just tell what are the places where machine learning is already taking place in our daily life with the small devices which we carry? Any insights which you can share with the group?
Okay, the best example is okay. I can put this in two ways. One, a machine learning has already happened and it is coming up. Like whenever you are typing in WhatsApp, I think in the latest versions of WhatsApp, in the initial days, it could not predict the word that you are about to type. Okay, maybe the words like suppose you are typing a local language like SHIV Shiva. Initial days, WhatsApp could not predict that one. If you type SHI, it will try to predict an English word. But now, based on your data, past data usage, it will type that you are most likely to type SHI means the next thing would be SHIV Shiva. That is where the machine learning is happening. Already happened and it is showing the results. But if we are sitting now and want to see any machine that is actually learning, it could be Amazon's Alexa. Okay, it is both a plus and minus to the systems. Okay, imagine you have Amazon Alexa behind you, and it is hearing my voice. Okay, so it has obviously learned something about machine learning, just like the way you have done. Okay, so tomorrow if you ask it about machine learning, it might reiterate the presentation to you. That is what is. So if you take it to our IT day-to-day lives, yeah, voice recognition systems are going to be the most threatening challenge to us in terms of cyber security. Suppose if we have voice-activated devices, then they can learn from us and they can also give the commands on their own. So there is some kind of vulnerability over there. We have to overcome that before we install them in our day-to-day activities. I hope that answers the question, Shiva. So would you like to know anything else? Okay, anybody else? Would you like to know anything about this presentation that I made or anything else on this one? You can even type your questions in the chat if you want. Okay, for a moment, now that I have, while you people are thinking about your questions, okay, I would like to take this opportunity to test whether my machine learning algos are working fine or not. Okay, can any volunteer type their age here if you are okay with it? Can any volunteer type their current age?
That's a tough question.
That's a tough question, right? I know, Ganesh. Yeah, that's a tough question. Okay.
So someone can type,
Yeah,
I
yeah,
think, in the group chat you're
yeah,
telling.
yeah. Anyone can type this in group chat. So it is indeed a tough question. Nobody is answering it over here. Okay, fine. Okay, 40. Fine, good. So let me go by this one. So if you are okay, if your current age is 40, I'm not going to name the person here. If your current age is 40, then okay, fine. Uh, Let me predict. Do you watch Hindi movies? The person who has just typed here, 40 years. Okay. If you watch Hindi movies, then I can, my main guess is 80% or 90% I can say, Dilwale Dulhania Le Jayenge is your very favorite movie. It is one of the movies of your good type. Suppose if somebody wants to give, if somebody gives that Dilwale Dulhania Le Jayenge or Kuch Kuch Hota Hai, one of those two movies, you will find it, you'll be happy. This is what my machine learning thing is. So can you just tell me whether I'm right or wrong? If you watch Hindi movies.
Yeah, you're kind of right. If
Okay.
you have
And
given me
you,
only two options, maybe I'll choose that because
no.
that's a better entertainer.
Okay, okay. It's not that I gave two options. Like the point is, I'm trying to narrow down. If I have to choose only, I have a very narrow list. Then I will choose this and give it to you. Okay. So the intention is that what the machine learning things have found out is that people when in India especially or from Asian countries, people when they are in the age of 18, okay, whatever the movies they see, they are going to be their most favorite movies, which are likely to last throughout their life. I mean to say, when they become a bit retired, okay, maybe in the 50s or 60s, they would like to fall back and watch these movies. And they found this age group to be 13 or 14 years in USA and Europe. So suppose if you have a client or a manager who is 40 years now, so you have to just go back 26 years from now, say in 1992, and you can talk any of the movies like 1992 Europe means Terminator 2 Judgment Day. So if you talk about that movie, the client will be easily interested. So that is what is machine learning for you.
So I have one more question, Rajesh. See,
Mhm.
when you look into the enterprise architecture, when these kind of big companies try to do a machine learning, uh,
Mhm.
both supervised or unsupervised learning, how do they do it? They generally have a bigger data warehouse, as I
Yeah,
understand.
that's
From
correct.
the data warehouse, they will build up a separate application for ML, and then they use the data lake and train using data and come up with patterns, or how is the application, or where it fits in the enterprise application map generally?
See, if we are talking about the enterprise application architecture, basically now majority of the firms are focusing on hosting of the data. Okay, because as I said, data acquisition is the major challenge, and that is in demand. Okay, so majority of the enterprise architecture focus will lie on data acquisition only. Now, how does machine learning come into picture? It comes from the use cases that the business is trying to develop. Say for example, that particular use case of vehicle density for Puducherry, it happened because one of the banks want to predict what could be the vehicle density in Puducherry, and can we offer vehicle loans here? Is it feasible or not? So that kind of a use case comes up, and then based on that, the data will be fetched. The data search happens. Okay, so now if you ask me, the question can be in any way. So that's why the organization of data is no longer an important thing. So that's why relational database is not going to be helpful. So I tomorrow I can come up and ask not just vehicle density, I can come up and ask, based on number of children, I want to predict the vehicle loans that are likely to be accepted, or number of vehicles that are going to be sold. So how do I get children and vehicles? So that's why they are going to host NoSQL. In this case, they will host the entire data in NoSQL, and then they will pull up this data later based on the use case.
Okay. Okay, thanks, Rajesh.
Yeah.
So team, do we have any other questions?
One last question I have. So, if given an option, Rajesh, uh, R, VB script, SQL, and Excel, which is the better option for machine learning?
Okay, can you please repeat, Shiva?
Okay, given an option that I can choose a language to understand machine learning and this one, is R better than VB script or VB script better than R SQL structured query language? Which one is the best?
Okay, so if you ask me, I think comparison is not easy between R or VB script or structured query language. Why? Because structured query language was intended to query the data and retrieve the information. That's all. After that, there will be BI tools to analyze the data. But R is like it has got the statistical tools, all those standard algorithms that I have just explained to you, the linear regression or k-means or association rules. So that is, so if you ask me, if you want to learn machine learning and if you have these three choices, then you can easily choose R. But now the difficult question is somebody says whether you have to choose R or SAS or Python, which is going to be important. These are the general machine learning languages that people prefer. So then it is again based on the enterprise utility. Generally, for enterprise utility, these days Python is being preferred. That is a preferred language. But I have showed you Octave and MATLAB. There used to be the ones who which were the initial process, which were the initial languages. Python and MATLAB. For learning purpose, Python and MATLAB would be helpful. But if you want to use in enterprise, then Python is the best one, actually. If you are, in my personal opinion, then you can take up R and all because it is getting wide amount of acceptance these days.
So we have one question from group chat, Sujay. Rajesh, can you take a look into it? I think that can be a last
Where do
question.
I start if I want to learn learning? So, Sujay, I suggest that you can enroll yourself in Coursera. It is machine learning by Andrew. And okay, this is a free course in Coursera, and this is where I have learned the machine learning myself. Okay, so people from all backgrounds can understand this course and learn it. There is some amount of programming involved. If you are interested in programming, you can do the programming. Otherwise, you can just get the concepts and understand. If some tomorrow in your projects, if somebody is talking about machine learning, you can understand that concept easily. So I suggest that you start from here. And then if you are interested in programming, then much more, you can join Udemy Python. Okay, there you can learn the Python language. Coursera also have this, and many other people have it. But my information says that Python from Udemy is good one. Okay,
Okay, I think
what is the difference? Sorry, Ganesh. I just got one. What is the difference between machine learning and artificial intelligence? Okay. As I told in the start, machine learning is the stepping stone for artificial intelligence. Say, for example, in this figure that we have just seen, okay, I'll share the screen again. I hope you can see my screen, Satish. So you can see here the system has learned itself to make the move and identify the clusters. Okay. So if we train the system in vast amount of data like this, then my computer has got the ability to learn and take a decision or make a move. So that make a move thing is called as artificial intelligence. And the starting steps, the baby steps it was taking to learn this is machine learning. So machine learning is a part of artificial intelligence, and you'll use machine learning tools to bring some kind of intelligence to the system. And when the system becomes intelligent, and obviously it is artificial, so that is when people call it artificially intelligent. So what I have demonstrated here is machine learning, and if you develop this algorithm and use it for chess moves, okay, then it is artificial intelligence. I hope I have clarified your doubt, Satish.
Okay, I think we are on time and track. Okay, so uh, I would like to thank Rajesh. Rajesh, thanks for your time and spending with us, making us understand the basic concepts of ML. Hopefully, I think
Yeah.
the future references you have given is also of great help. So we will also share this presentation and get it uploaded in our chapter website so that it is useful for everyone.
Yeah.
So I would like to thank Rajesh on behalf of Hyderabad chapter of ISACA for spending his valuable time and helping us understand ML.
Yeah. Thanks, Ganesh, and thanks everybody for your valuable questions and for your enthusiasm to learn on a weekday like this one. Thanks a lot.
Thank you. Thank you. Thank you so much. Thanks, everyone. Have a great day. Thank you.
Appreciate it, sir. Bye.
Bye bye.